Hi, this is Electricity Fundamentals for Solar Engineers. Okay, so this right here is MX Academy of Technical and Creative Arts. Okay, this class right here is for electricians that wants to upgrade their knowledge with solar technology skills, and also for newbies who wants to learn solar engineering technology. Okay, this class is intended for those who are aspiring to become solar engineers, for electricians who wants to upgrade their knowledge by adding solar engineering skills. So if you are someone out there that you don't have any electrical knowledge and you want to learn solar engineering, and you are scared, you are thinking that, hey, you don't know anything about electricity and electronics, so you think that learning solar engineering is going to be difficult for you, you don't have anything to worry about. So in this class right now, I am going to break down everything that you need to know about electricity. So when I say everything, I mean everything that you need to know about electricity. Okay, so as a solar engineer, essentially what you are going to be doing is you are going to be providing an alternative source of electrical power for your clients. Okay, so if your work is going to revolve around providing alternative forms of electricity for your client, then you need to be fully grounded on electricity. So you need to you need to know very well everything that needs to be known about electricity, and that's what I am going to teach you right here. So I am Philly, the Tech Wheezy, and join me right now on this class at MX Academy. Okay, so now let's go. So in this class, I'm going to be covering all the electrical concepts. So I'm going to talk about electricity itself, current, charges, voltage, resistance, the different types of circuits, series circuit, parallel circuits. Talk about watts, wattage, kilowatt hour, volt amperes, kilovolt amperes. Then talk about the relationship between kVA and watts, and the confusion between the two, why some people used to confuse watts and kilowatts to mean the same thing as kVA. So we'll talk about it, and we explain to you the differences, the relationship, and also how to convert from kVA to wattage and how to convert from wattage to kVA. Then we'll talk about the different types of electricity, single phase electricity, three-phase electricity. Talk about also alternating current, direct current. Then we'll talk about safety. Okay, safety, very important. So talk about safety. We'll talk about grid, the grid system. Talk about on-grid versus off-grid. Or you must have been hearing about off-grid, on-grid. What does it mean to say off-grid and on-grid? Okay, so we are going to break down all these terminologies. Talk about earthing, grounding, what is the difference between earthing/grounding and the lightning/thunder arrestor. So what's the work, what is the difference, what are the similarities, circuit breakers, what do they do and why do we need them. So basically, like everything that you need to know in the electrical aspect, I am going to teach you right here, right now. So without wasting much of your time, let's get started. Okay, so I am Philly, the Tech Wheezy, and I'll be your pilot in this training series. So let's get started. So what is electricity? Electricity is a form of energy resulting from the flow of electric charge. According to the scientifically approved curriculum, or should I say what is allowed to be taught in schools, what has been approved to be taught in schools. Okay, so watch the different ways that electricity can be generated includes electromagnetic induction, chemical reaction, and through photovoltaic cells. So electromagnetic induction, an example is when you are using things like your gasoline and your diesel generator. So there is an electromagnet, there is a magnet that spins inside. So that rotation of the magnet creates an electric field, and from there electricity is being generated. Then chemical reaction, in the case of battery, So in your battery, what's happening inside your battery is a chemical reaction, and that is what is generating the electricity. Then the other one, photovoltaic cell. Photovoltaic refers to solar panels. So the art of harnessing the energy from the sun through the solar panels. Okay, so these are the ways that electricity can be generated. So this is the scientifically approved knowledge. Okay, but if I'm allowed to go outside of that, then you get to understand that there are just so many ways that you can achieve electricity, and electricity does not need to be generated, because in school we are taught that you generate electricity, but that's the knowledge that we are being taught in school. You know, school basically is not a place to get education. School is where people are miseducated. School restricts your knowledge, and it restricts how you think to just a particular line. So what school is doing is that school is just restricting your scope of knowledge, restricting your thoughts. So restricting your thoughts so you can think in just one or two directions, and that direction you are going to think is the direction in which you are being educated on. So in school we are taught that electricity is generated through means such as electromagnetic induction, chemical reaction, and through photovoltaic cell. But in reality, electricity does not actually need to be generated. Now, the thing a lot of people do not understand is that electricity is a form of energy. It does not need to be generated because it is already present in every aspect of our life. I'm not talking about the electricity that is being provided by your government. Without the government provided electricity, there's electricity for the earth to work, for the rain to fall, for the water in the ocean to move, for that thunder, for the lightning, for almost all the different phenomena that happens on the earth crust. For it to happen, there is electricity. Without electricity, none of these things can happen. Without electricity, there will be no rainfall. Without electricity, the water on the oceans are not going to move. They are not going to flow. Okay? So, for the earth to rotate on its axis, is doing so due to the electricity that it has, the electricity that is present on the earth crust. So many things in life generate electricity. So we as human beings, we only need to learn how to tap this electricity that has already been generated, because electricity exists freely as an energy in different forms. So we as humans are supposed to learn how to harness this energy and make use of it. But then the school system restricts us in this knowledge. Instead, they teach us how to now start generating electricity afresh instead of using the already generated electricity which exists naturally. So this is where we draw the line. So I'm not going to go further here. So let me teach you the ones that has been approved to be taught in school. Okay, before I get arrested, they say I'm teaching people forbidden knowledge. Okay, so let's get ahead. So with the ones that is approved to be taught in schools, so let's go how to generate electricity, different things. The basic concept of electricity. So electricity, like I said, is a form of energy resulting from the flow of electric charges. Then what is a charge? An electric charge is a fundamental property of matter that causes it to experience a force in an electric field. Now there are two types of charges. So you have the positive charge and the negative charge. The positive charge is represented by the positive sign, which is the plus sign, while the negative charge is represented by the minus sign. And also remember, positive charge is usually referenced with the red color. So while the negative is either with black or blue. So when you are running your connection, always check. You see that when you are going to connect your terminals, you always see, like here, this is red and this is black. Then this red one, there's a plus sign here, and on this black terminal there's a minus sign here. So the positive terminal is represented with the plus sign and always with the red color, okay? It's denoted with the red color, while the negative terminal, the negative charge, is represented with the negative sign and black color, or sometimes maybe blue color. So if you are going to run your connection, make sure that the red wire goes on the positive terminal while the black wire goes on the negative terminal. So anything other than that is wrong connection. So now let's talk about current. So what is current? Current is the flow of electric charge in a circuit, okay? It is used to measure the amount of electricity that is flowing through a conductor, basically. So, and it is measured in amperes, okay? So practically, how do we explain current? Current is the electricity, the electrons, the electric charge that is flowing through your conductor, which is, now a good example of a conductor is your electric wire. So this is a conductor, okay? So the electric charges that flows through this wire when connected is the current, and is measured in amperes, okay? There are two types of current based on the direction of flow. Now you have direct current and alternating current. Alternating current is the type of current that alternates in direction, while direct current flows in one direction. Now practically, what does this mean? Like I explained to you earlier about charges, we have positive and negative charges, and the positive is represented with the red color and the plus sign, while the negative is represented with black and minus sign. Alternating current. So what's the practical way of explaining the difference between DC and AC? So DC stands for direct current, AC stands for alternating current. Alternating current is a form of electricity that reverses direction. Now what does it mean to say that it's reversing direction? What it means is that when you've connected the positive, like this is the positive wire, when you've connected this positive wire to the positive terminal, and you connect this negative to the negative terminal from your output, let's say I connect it here, okay? I connect this to a socket. So after I've connected this to a socket, now you want to connect your electrical appliance. It doesn't matter if you connect positive to positive or negative to positive. Whichever direction you connect your appliance is going to work. So like this one right here is a phone charger. So if you plug it this way, it's going to work. If you rotate it and you plug it, it's still going to work. It doesn't matter if the positive is on positive or positive is on negative. Now if you take note, you see that this thing is not rated positive and negative. Why? Because it's an AC charger. So an AC, for you to plug something in AC, it doesn't matter if you put it on the positive or the negative, because it's constantly changing direction. So what it means that there's no more positive and negative on the end point. But if it is DC, you must make sure that you adhere to the positive and negative terminals. So the positive must be connected to the positive, the negative must be connected to the negative, and even at the end point, whatever you are going to connect, you must make sure you adhere to that positive and negative connections. So if you mistakenly connect negative to positive in DC, it's going to short circuit and it can burn the equipment you are using. But in AC, if you connect positive to negative and negative to positive, it works, no problem. Why? Because it's constantly changing direction. That's why it's called alternating current. So it doesn't flow in just one direction. Okay, so practically, alternating current is the type of current that is provided in homes. It's the type of current that is provided by the national grid. Also, it is the type of electricity current that is provided by gasoline and diesel generators. It is the form of electricity that is needed to power up appliances such as your TV, your refrigerator, your electric cooker, water pumping machine, and the rest. Okay. While DC, direct current, is the form of electricity that is provided by power sources such as PV, which is solar panel, and batteries. Okay, so batteries provide direct current, solar panels provide direct current. Okay, so a lot of you, for those who are complete novice into solar power, so solar panels does not produce alternating current, so solar panels produce direct current. So the work of an inverter is to convert direct current to alternating current. So in a solar panel setup, there is something called inverter. This is an inverter. So the work of an inverter is to convert direct current to alternating current, because alternating current is the current that is needed to power the electrical appliances that we have at home. Okay.